Okay, nerds, we did it. This is the last section in topic 1. Woohoo! Unit 1, topic 1, whatever you want to call it. This is the last one. Yesterday, we were finding regressions, right? We used the calculator to turn tables of data into straight lines, called linear regression, and into quadratics, called quadratic regression. As it turns out, you can use tables of data to develop any kind of model you want. But that doesn't necessarily mean that the model is good. If you recall, when we did the linear regression on this one with its scatter plot, if you remember, it wasn't a very good model. There's data way far away from the line, if you recall, from yesterday's notes. So what we're going to do today then is, well, one of the things we're going to do today, we're going to produce a model from this data that is linear, one that's quadratic, and one that's cubic. And then we're going to look at the graphs and see which one fits the best. Cool with that? All right. Boop. So we will start by firing up ye olde calculator. Let me get off of here. And we need to build out our tables of data. We do that with stat edit. So stat edit. Oh, I got to clear my tables of data. Clear, enter. Clear, enter. There we go. Fill out your tables. It's only 5 points, so it shouldn't take too long. Boom. So we have our 5 coordinates in here. We're ready to rock and roll. We're going to produce 3 different models. We're going to produce a linear model, a quadratic model, a cubic model. So we're going to have to do the regression for each one of those. The cubic regression is in the exact same place as these two. In fact, it's right below quadratic regression. It's in stat, calc, yada, yada, yada. But, I want to store them all as different functions. So we're going to have to store the first one as y1, store the second one as y2, store the third one as y3. Okay? Because if you go to your y equals menu, you can actually graph, I think it's 10 equations. Yeah, it'll graph 10 things at once. So we're going to store something as 1, 2, and 3. And those colors are blue, red, and black. So that's what I'll write the answers in as well. Okay? So stat, calc, start with linear. That one will be red. Make sure your X list is Y1. Make sure your Y list is Y2, L2, excuse me. And store this as Y1, vars, Y vars, functions, y1. And it will copy paste this into the y equals menu for me. That one I don't even have to round. It did it for me, which is pretty good. And I said that one will be in blue. So our linear model is y equals 0.572x plus 5.34. All right. Then we're ready to do our quadratic model. Okay, ready to do our quadratic model. Stat, calc, quadratic regression is option 5. Boink, I just hit the number 5. Store this one as y2. So vars, y vars, vars, y vars, function I said, that one's y2, and that one will be in red when I graph it. Calculate. There it is, in red. We now have, we're going to have to round this one. That stinks. Oh well. Y equals 0.059x squared minus 0.617x plus 8.311. Now, like I said, it's now stored that in as y2, just to double check. It's there. Okay. Second mode does quit for me. Time for the cubic model. I wish I did that one in green, but it doesn't. It does that one in black. Stat, calc, scroll down to cubic regression, and you might have noticed it'll also do quartic regression. So fourth degree polynomial is the last polynomial that it can find for us. Okay. This cubic model, enter, store it as y3. Vars, yvars, function, y3. We're going to have to round this one also. Yuck, look at all those decimals. Y equals negative 0.012, I guess. It's unfortunate that I have to round this because this is a repeating decimal, which means this can actually be written as a fraction, but we don't have a choice. X to the third, and then 0.433 x squared minus 3.297x, get skinny math, plus 10.181. There it is. Cool. The next question actually asks us which one appears to fit the data the best. And the way we're going to decide that is by putting a scatter plot up and seeing which model gets closest to most of the dots. So go to y equals. We have to tell the calculator to turn on our scatter plot, which means we have to highlight plot 1. So go up and hit enter. And let's be intelligent about our window. The smallest x is 0. But if you let the minimum x value be 0, it's going to try to put one of those scatter plot dots on the edge of the screen. So I have my window set at -1, so a little bit left of the data. And the same thing here. I could go out to 20 if I wanted to, but then I'd have a dot right on the edge of the screen. So maybe go out to 21. I don't know. Just maybe go out to 21. This way it doesn't try to put a dot right on the edge of the screen. And have your x scale go by 1. So that'll give me 22 tick marks, but whatever, that's fine. Your y minimum is your y minimum is 2.9. So your y can go from 0 up to your maximum, which is just under 18. So I have it go from 0 to 20. This way, none of my dots is right on the edge of the screen. So the x's go from -1 to 21. The y's go from 0 to 20. When we hit graph, we'll have 5 dots, and then it'll draw 4 equations. There's my 5 dots. There's a straight line. There's the quadratic. And the black cubic. So which one appears to be the best model? The cubic. And what's your explanation for that? It pretty much hits all the points on the scatter plot. So you could see that the cubic is the best one. I'll write it in green since I was hoping that it would graph that third one in green. Cubic, because B/C is because it gets very close to all data points. Now I will tell you this, it's not a perfect model. It's not perfect. It got close, but if we zoom in, we'll see that it didn't hit them perfectly. You can see this one is at the bottom right-hand corner of that dot, and this one's at the bottom left-hand corner of that dot, and this one's at the top left, so it's not going through the dead center of all of them. But man, is it good. It's really close, right? It says, use your best fit model to predict the value of y when x equals 25. There's a little bit of discrepancy here. We were told to use our model. This is the model that we have to generate according to AP's rules of rounding to 3 decimals, right? That means in order to use this model, I have to actually plug into this, not that the calculator generated. And the discrepancy is actually very large, unfortunately. If you plug into what the calculator model is here with all the decimals, we get an answer that's like 3.38. We're about to get an answer that's bigger than 10. So it's way off. But it is what it is, and we were told to use the model. So how do we use the model? We literally just plug in 25 here, here, here. That's it. Okay? So we do have to type a lot of stuff. Just make sure you are careful. Negative 0.012 times 25 raised to the third.
What did you do with the screen? You lifted something.
I didn't do anything in there. I was just showing you that we can't use y3's actual. We had to round it. This is what it is when we round it. Now we're plugging into this rounded equation. Plus 0.43325 squared minus 3.297 times 25. Uh-oh, that would have screwed me up. I missed the plus sign. In case you ever have to do that and you don't want to delete everything, second delete is actually the insert key there. That's what INS stands for. Plus 10.181. Then you hit enter. And I clearly missed a plus sign somewhere else as well. Where is it?
Why'd you put a plus sign plus 3.2?
Oh, was I typing it correct?
Yeah.
Well, see, I screwed myself up. No, I didn't.
You put a plus 3.297 when it's minus.
Oh, that's what you mean. There. All right. Good call. Good call. There we go. That's the number I was expecting to see. Mistyped. 10.881. And like I said, if you ask the calculator to give you the value at 25, it's going to say 3.38. And just to show you how to do that, you'll notice that I still have clear. This is the cubic right there. Yes? And if I get rid of the plot, and I'm going to actually submit a graph. So this is the cubic model, and we can use the calculator to find y when we know x. You do that by doing second trace value. And it says, oh, well, at what x value did you want me to do this math? And I say x equals 25, and then you hit enter, and it throws an error. Error, invalid. Attempted to use a variable or function where it is not valid. Here's what happened. My window only went out to x equals 21. So the calculator couldn't do math there. There. So I'll change it all the way out to 25, and now it'll let me plug in x equals 25. But when I do, I get a number that's wildly different from 10.881. Second trace value at x equals 25, and it says the answer is 3.86. So wildly different. Goes to show you how much things change when you round to 3 decimals. But that's what we were instructed to do, so that's what we did. Second trace value.
I'm pressing that. Oh.
Then you type in 25 and hit enter. Okay? There it is. As it turns out, the perfect model, the perfect 100% perfect model is a 4th degree polynomial, a quartic. But how do I know that is the question. This question tells us to take these 3 coordinates and write the equation of a parabola. How many coordinates do you need to write the equation of a straight line? 2 coordinates makes a 1 degree polynomial. Turns out 3 coordinates makes a 2 degree polynomial. 4 coordinates makes a 3 degree polynomial. And 5 coordinates makes a 4th degree polynomial. Now you don't have to know that for this course. It's just a truth, and it's stinking cool. So if I had asked the calculator to do a quartic regression, the model it produces is perfect, 100%. It goes through the dead smack middle of all 5 coordinates. But that's just because I'm a nerd that I know that. But you know what's up? Do you guys remember systems of equations from Algebra 2? 3 equations and 3 variables with all the crazy eliminations? That's how you do this. Guess what? It's not in our curriculum. Moving on. It's something that we could do after the AP exam if we have time. But you don't need to be able to do that for the AP exam, okay? Okay. Now, The rest of these notes is all about real-world applications of what we're doing. What does that mean? It means word problems, okay? So we won't be doing any more regression. You've seen all your regression now. We will still utilize our graphing calculators a little bit, but somewhat more as a calculator, less as a grapher, okay? So I'm just clearing the screen and shutting it off for now, off to the side. Writing functions from formulas. Just sit down, you need it for a minute. The perimeter of a rectangular garden is 84 feet. We could use a picture here. Ooh, my black pen tried to pop. You see all that? Blob of black ink right there? Whose pass is this? I don't even know whose pass this is. Oh, does I say Walter? It's Walter's pass. I'm trying to soak up the extra ink. Walter's pass. Whatever. Rectangular garden. Perimeter is given to us. Can we agree that perimeter is found by adding up all four sides? Yes, awesome. Since this is a rectangle, it has 2 widths and 2 lengths. I'm a fan of cursive L's for some reason. Here's what we know. The equation for perimeter is 2W plus 2L. We know that to be a fact. Oh, and we were told what that perimeter equals. It equals 84. Coolio. Let's see what else we have going on here. Express the area as a function of the width. Well, area of a rectangle is length times width. It says to write the equation of the area so that W is our only variable. That means I need to replace L with something that only has W's in it, so that this is built out of only W's. Luckily, we have this expression for perimeter, because we could solve for L here. We can isolate L and substitute it right there. Let's get L alone. (84 minus 2W is 2L. And if you would like to get L alone, just divide everything by 2. That gives me 42 minus W is the length of my rectangle. And now that I know what the length of my rectangle is, I could take this expression and I could substitute it right there. The area of my rectangle with only W as its variables is 42 minus W times W. There it is. All done. What do you mean solve? The word solve means use one unknown to find another unknown. I have 2 unknowns though, so there's nothing to solve. Now, if you gave me an area value, could I use my graphing calculator with second trace intersect to figure out what width would have made that work? Yes. But because I don't have a known area, all I can do is write an equation for the area. Okay? Don't distribute. You want to leave it like this. What would be the degree of this polynomial? This is degree 2 if you FOIL, right? If you distribute?
Yes.
That makes it a quadratic. Does it point up or down?
Up. Down.
Which one, up or down?
Down.
The reason why it points down is because this W squared will have a minus sign in front of it. What does every downwards parabola have in common? What do they all have? All downwards parabolas. They all have a maximum. And the maximum will always be halfway between its 2 zeros. Those zeros are 0 and 42. The area maximizes when the width is 21. Now, that wasn't what the question asked us to do, but this is why we want to leave them in factored form, because you're often being asked to maximize things. Cool? Yes, Mr. M. Awesome.
Mr. McCutcheon,
Next, oh, by the way, if the length is 21, if the width is 21, so is the length. 21, 21, 21, 21. That makes this rectangle a square. If you didn't already know this, the area of a rectangle is maximized when that rectangle is a square. Now you know. That's always a truth. Boop. The volume of a right circular cone is this. A right circular cone is just a cone that isn't slanted. It's the, I don't want to call it the vertex of the cone, is directly above the center of the circle. So it's called a right circular cone because that would make a right angle. There. I just wanted you to know that. You don't even have to draw it because there's one right here on the next page, okay? But I just wanted you to know that's what that means. The volume of this object is 1/3 pi r squared h. If the height is twice the radius, comma, not period. Oh, whoa, whoa, whoa. Height is twice radius. Height is 2r. Express the volume as a function of r. Oh, that means only have r in that volume equation. Simple. Replace h with 2r. There you go. Use purple. Volume is 1/3 pi r squared. Here's h. This is not distribution. This is just multiplication. Every one of these objects has a multiplication dot in between it, so this is not distribution. I'm going to clean this thing up a little bit. 2 times 1/3 is 2/3. R squared times r is r cubed. There is the volume of your cone if the height is twice as long as the radius. You have question face. Would you care to air the question?
Where's the 2 times r coming from? So,
Height is twice radius.
okay, I see that. And then how do you get the 2/3 pi r cubed?
Good. What is 2 times 1/3?
2/3.
Okay. And r squared times r?
R cubed.
There you go.
So what about the pi?
There it is.
So what about 2 times pi and r times pi?
What are you talking about? 2 times pi r times pi. There's no times pi twice. This is, it's not two sets of parentheses. And there's no plus signs. There's no distribution.
Oh.
It's literally just 1/3 times pi times r squared times 2 times r. That's it.
Yeah, but how do you know where to multiply the 2 into? Like, why don't you put the 2 into the r squared? 2r squared.
I did. What's 2r squared times 1/3? It's 2/3 r cubed.
Buster, I did not ask you.
Yeah, stop it, stop it, stop it. The order of multiplication doesn't matter, so why wouldn't you put all the numbers at the front?
Because there's better places to put
No, that's the best place to put it.
it. Yes.
I mean, I could even do this if I wanted to. That's the same answer. Because since these numbers are not in the bottom of the fraction, they're automatically in the top of the fraction.
I don't know why this is confusing me so much. It's all crazy.
I don't know, a little bit of 6th grade math is biting you on the butt, that's all. All right. Find the volume of a paper snow cone cup whose radius is 2 inches. Literally plug in r equals 2. So volume is 1/3 pi, and then your radius cubed. Oops, I forgot my 2. Sorry. There you go. And what is 2 to the 3rd power? 8. 8 times 2 is 16. So this volume is 16/3. It says r is 2. Okay. So 16/3 pi, and That's if I want to use the pi symbol instead of the actual value for pi, which I'll have to use my calculator for. So 16 pi over 3 is actually even better answer, 16 pi over 3. And this is a volume, so it's cubic inches. You can either write cubic inches or you can do inches cubed. Means the same thing. Cooper?
What's the top number of the
2. I wrote a 1 by accident, so I just wrote over it with a 2. Oh, it's not a 4. If that's it's no. It was a 1 by accident there. 2/3 pi. So 16 pi over 3. Cubic inches, whatever that is. If you care. 16. The pi button is right there. So second pi. So 16 pi divided by 3 is that number. But look how much prettier it is to say that than it is to round and say 16.755 cubic inches. Isn't that pretty? Nice and just organized and not rounded and exact. Oh, let's write it in parentheses. 16.755. But I like 16 pi over 3 better. Okay? Everybody all right? Yes? Nobody's panicking. Good. Return to the page. Boop. Hey, look. Here's that right circular cone again. This time, we're going to describe a real-world problem. Grain is leaking through a hole in a storage bin at a constant rate of 6 cubic inches per minute. So this is a volume per minute situation here. The grain forms a cone-shaped pile on the ground. As it grows, the height of the cone always remains equal to its radius. Oh, the height of the cone is equal to the radius. So I can either put an R here and here, or I could put an H here or here. Doesn't matter because they're equal to each other, right? All right. I'll just put an H in both places because it says the height and the radius are equal to each other. There we go. So volume of a right circular cone from the previous example was volume equals 1/3 pi r squared h. But our r is equal to our h. So instead of saying r squared, we could have said h squared here. And h squared times h is h cubed. So there's a volume of our cone using height. Great. If the cone is 2 feet tall now, how tall will it be in 1 hour? Now here's a problem. This is 2 feet tall. That's feet. The question mentioned inches before. So we either need to convert our 6 cubic inches into cubic feet, which is painful, or we can convert our 2 feet into inches, which is 24 inches. That one's really not that bad. Great. Here's what we know. We know that our cone is 2 feet tall. So if we know our cone is 2 feet tall, we can use that 24-inch height to figure out the volume of our cone now. All right? Let's find the volume of our cone now. That volume is 1/3 times pi times 24 cubed. Eek! That is going to be a big, big number. So, 1 divided by 3 times pi times 24 to the 3rd power. This is going to be a large number. 14476.459 cubic inches. The question says, how tall will it be in 1 hour? But the problem is, in 1 hour, when this was told in minutes. So that 1 hour is actually going to be 60 minutes. Our volume was growing by 6 per minute at 60 minutes. 6 per minute for 60 minutes is 360 cubic inches was added. 360 cubic inches was added. So there is our new volume. Our new volume is 14836.459. And the question wants to know, how tall will our cone be? Luckily, we have an equation for the volume in terms of height. And now we solve for h. I would multiply both sides by 3. (44509.377) equals pi h cubed. I would then divide both sides by pi. And I would have that h cubed is 14167.775. And how do you get h alone? What cancels the third power? The cube root. So you need to do the third root of both sides. You can either know how to do third root on the calculator, or you could raise both sides to what power? What power is the same as the third root? 1/3 power. So it doesn't matter which one you choose, but you might as well know where the cube root is. Math. 4. And another reason why I love this calculator is because of that command right there above my negative symbol, ANS. That means last answer. So where it's flashing, I'm going to hit second and then the negative key, and it inserts the last answer it found, which is that number. And then I can hit enter, and I can get 24.197 24.197, and now I just need to know what the units is. Well, this was inches cubed when I used 360, so this is inches. So you might have noticed that the height barely changed. Well, that's because 6 cubic inches really isn't much when you're talking about this cone. It was a huge cone with a massive volume. Yes, Walter?
How did you put in the square cube?
The cube root, the math command,
Yeah.
and then scroll down to option 4. That is quite the involved question, isn't it? Yeah, yes?
Why did you choose cube root?
Because that's a third power. You cancel third powers with third roots. All right, the variation problem at the bottom of this page. I'm not going to worry about inverse and direct variation, so we'll just do that. Okay? And now if you were to flip your paper over, you will notice that the back of your notes are blank, unless you are David or Uriel, because I've added an example on the back of these notes for future students. And since I added it after I ordered these notes, everybody in the room has a blank on the back except for those two gentlemen. In the last 5 minutes, you are all going to write down this example, and we will finish it I don't know, tomorrow or something off camera. Okay? Just so you know, so you can see the scale of this thing, that's the top of the paper. Well, you could choose not to write it, but you'll be missing out on a really important example. That's up to him. I don't care. A square of side x inches is cut out of each corner of an 8.5 inch by 11 inch piece of paper, and the sides are folded up to form an open top box. A standard piece of paper is 8.5 by 11. Computer paper is 8.5 by 11. I wanted to make this question real world. She's taking a picture of it. It's going to be on the video on YouTube. Anyway, it says write the surface area and the volume as a function of the side of the square that is cut out, x. Part B says state the domain of both functions. Can I push the paper up yet, or do I still have people writing part A? He's still writing part A. Okay? Can I move it yet? Killing me. Got just dead air in the video right now. I just need to move it up so we can see part C. Are we done writing part A yet? Oh man.
A correction from this morning's announcements. The water polo.
It's good we're gonna get the announcements in the video.
People who are interested in water polo is actually tomorrow.
I was going to that.
Can I please push the paper up yet? Jesus. Part C says graph the functions to find the sides of the square to be removed in order for the surface area and volume to be equal to one another. And now that question is bomb diggity. This one's from my own brain. That's a good question. It's feeling good. Anyway, I'm going to cut the video off there because you all can keep writing after I hit stop. So even though we've finished the official notes, we are officially finished with topic 1. We'll just do this question tomorrow before you do review, just because it's interesting. Okay? Is the question important to the video before I hit stop? No? All right. Thank you, nerds.